Hello, and welcome to today's lesson where we're going to work with calculating the surface area of a sphere and the surface area of a hemisphere. So when we look at the surface area of a sphere, our surface area formula, think about the fact that it is area, so we know that it's going to have a pi and a radius involved. Okay, since it is area, it would have to be a radius squared. It couldn't be a radius cubed. So if we look at this, this is actually the circle area formula. Now, if we want the surface area for a sphere, all we have to do is tack on a 4. Okay, it's a very interesting ratio between the area of a circle, or the area of the great circle, which is the circle that goes around the middle of a sphere, and the surface area for the entire shape. So if I want to find the surface area of this sphere, okay, surface area equals 4 pi radius squared. We have our radius value of 5, so it equals 4 pi 5 squared. 5 squared is 25, so we can rearrange it. 4 times 25 pi, and then we finish up by multiplying the 4 times 25. So our surface area is 100 centimeters squared. Okay, we always want to make sure we have proper units when we're finding surface areas and volumes. Okay, now, if we want to find the surface area of the hemisphere, we can find the area of the great circle, the surface area of the hemisphere, and we can see how the two compare to one another. So when we think about the great circle, okay, we know that a circle area is pi r squared. Okay, so we have a radius of 7. So pi 7 squared, we get 49 pi for the great circle around the middle of the base of this hemisphere. Now, if I want to find the surface area for the hemisphere, notice that it's half a sphere. So surface area equals 1/2 4 pi r squared. So 1/2 of 4 would be 2 pi r squared. But now here's where we have to be careful with the surface area. The hemisphere has the round shape on top, but it also has a circle for the bottom, and that is part of the surface. So we have to add on a pi r squared. So if we notice the relationship here, okay, hopefully we're seeing we've got 3 pi r squared for the hemisphere. We've got 1 pi r squared for the great circle. Okay, so this is a 3-to-1 ratio. Okay, so the surface area of the hemisphere is 3 times the size of the surface area of the great circle. So I can actually finish this problem up by not doing all the rest of the work. All I would have to do is 3 times 49 to get 147 pi, and we would have our centimeters squared. Centimeters squared. Okay, so we want to understand that relationship between the great circle, the circle that's at the base, and the overall surface area, okay, which includes the top portion, the rounded portion, plus the circle that is on the bottom. Okay, now, here's one of the toughest problems in your homework. Okay, so if you're willing to go through and watch this video, you'll actually have one of your homework problems taken care of, and it's our last problem of today's lesson. Okay, so now we're looking for the volume of this wigwam And we are also looking at the surface area of the roof. How much would it cover? Now notice it says of the roof, so we're not worried about the base bottom underneath. We're worried about the wraparound over the top. So let's deal with volume first. So in our volume situation here for this wigwam, what we see is we've got two pieces on the ends that would come together to be a hemisphere. So remember our volume formula for a hemisphere. 1/2 of 4/3 pi r cubed. So we would have 2/3 pi r cubed for the volume of that hemisphere when I bring the two ends together. And then around the middle, we also have 1/2 of a cylinder, and the cylinder is pi r squared h. Okay, so we have to bring those two pieces together. We have the two formulas here, so now we need to fill in and find the overall volume for this shape. So we have to be careful. We're given a diameter here, so we got to break the diameter in half to fill in our radius values. So we've got 2/3 pi 1.8 cubed plus 1/2 pi 1.8 squared times the height. And remember, the height is the distance between the two bases. So we're tacking on a 4 here. So now, this is just a big long string, and you just want to type it into your calculator carefully. Okay, we can do it a piece at a time. So 2 divided by 3, enter, times pi, times 1.8 cubed. Okay, so we've got 12.21 for the volume of the hemisphere. Okay, and remember that we're talking about meters here, meters cubed. And now the volume of the half cylinder. Okay, we've got pi times 1.8 squared times 4. And then we have to divide all that in half. So we've got 20.36. And then we just put those two pieces together. Okay, and I think they want it to well, they don't give us a rounding rule here in this problem, so I'm going to keep it to 2 decimal places just for some accuracy here. So we've got plus 12.21. We've got 32.57 meters cubed for our volume. Okay, and then just make sure that you check the rounding rule for any problems in your homework. Now, surface area will work the exact same way. What we have to do is we have to think about the surface area of the shape, and we're only talking about the top covering. Okay, so for our surface area, we have a hemisphere, so we need half of a full sphere surface area. And then we have the wraparound of the cylinder. Okay, so that is our cylinder wraparound, okay, 1/2. And remember, for the wraparound distance of a cylinder, we need 2 pi r, we need the circumference, and then times the height of the object. So we're putting these two pieces together to find that value, once again, using the measurements that were given in the problem. So for finishing up our surface area, we've got 1/2 of 4. Okay, let's do that one quick in our head, right? 2 pi radius 1.8 squared plus 1/2 of 2. So pi times radius times our height measurement of 4. And then what we're going to do is just multiply these pieces out and put them all together. So we've got 1.8 squared times pi times 2 gives us 20.36 plus 1.8 times 4 times pi, 22.62. Okay, we add those two pieces together, and we get 42.98. And that is meters squared. Okay, and that's the surface area over the top. If this question also asked for the base underneath, we would have a great circle and then a rectangle through the middle that we would have to add on. But this one only wanted the roof over the top. Okay, so that's why we didn't have to add on those pieces. Okay, one last problem here where we're converting back and forth. Find the surface area of a sphere whose volume is 36 pi centimeters cubed. So what we want to remember in this situation is we're going to use our volume formula, 4/3 pi radius cubed, to solve for our radius. So 36 pi equals 4/3 pi r cubed. Okay, and remember, we want to find some ways to make our work a little bit quicker. There's a pi on both sides, so we can divide those out. We want to multiply both sides by 3. So 36 times 3, 108. So we've got 108 equals 4 radius cubed. Now we can divide by 4. And we get 27 equals r cubed. Okay, now you've got two options here. You can guess and check what values, but remember we talked about before how you can get rid of the cube by using that 1/3 exponent on both sides. And we get a radius of 3. Now, you want to be careful. You're not done here yet. We found the radius, but now we have to go back and find the surface area of the sphere. So we have to plug it into our next formula, 4 pi r squared, to get our surface area. So 4 pi radius of 3 squared. 3 squared is 9. 9 times 4 is 36. So we finish up here with a 36 pi. And that concludes our lesson for today, looking at the surface area of a sphere and hemisphere and doing some connections to volume. Thank you and have a good day.